a user, remote control, and television. Is this an abstraction? In an abstraction, we have three elements: the user, the interface, and the implementation details. Here, the user is the person watching and controlling the television. The remote is the interface, and the television, along with its internal controls, is the underlying implementation. In abstraction, we don't interact directly with the underlying system. Instead, we use an interface to communicate with it, while the actual system stays hidden underneath, just like what's happening here. Abstraction is the act of hiding the underlying details. As we can see, the remote hides the complexity of what's actually happening inside the TV to make those operations work. A car. It has a driver who controls the car using these controls. These controls serve as interfaces, hiding the underlying implementation details. As drivers, we are interested in what to do, not how it works. How about a bicycle? A rider, a handle, and the bicycle. Is this abstraction? Let's think about it. What makes something an abstraction? Abstraction has three elements: the user, the interface, and the implementation details. Rather than interacting directly, if the user interacts with the system through an interface that hides the underlying details, then it's an abstraction. When the rider wants to turn the wheels, they don't do it manually. They use the handle. When they apply brakes or change gears, they don't deal with the mechanism directly. Instead, they use simple controls designed for ease of use. So yes, this is a perfect example of abstraction because we are using an interface to interact in a user-friendly way. Think about it again. The actual mechanism to stop a bicycle is to create friction by pressing brake shoes against the wheels. But the rider doesn't do all of that manually. They don't interact with the wheels directly. Instead, they apply the brakes using the handle, which stop the wheels without needing direct involvement. Imagine if they had to interact with the wheels directly every time they wanted to move or stop. What would happen then? Without abstraction, we wouldn't even be able to invent something as simple as a bicycle. Now before I proceed further, let me ask you a riddle. 1, 1 is 1. 2, 2 is 4. 3, 3 is 9. What is 4, 4? Let's ask AI. Correct? But the real question is, how did it know? I never mentioned that we are doing multiplication. So how did it figure it out? Because we gave few examples. And this is something the human brain is very good at. Learning through examples. So does AI. And that's exactly what we are doing in this video. What about a keyboard and a mouse? Of course, they are interfaces that hide the underlying details. There are a few things that you will find true for all abstractions. It's the act of hiding underlying details behind an interface. There is always a target user of that abstraction. The purpose is to facilitate the user's interaction, and the abstraction is designed for that user. Check these for any abstraction you come across and you will find them true. Here, of course, the keyboard and the mouse are hiding a lot of internal details. We just type the keys. How they actually end up written on the screen is all abstracted away. And of course, it's made for a user who wants to use a computer. It's definitely facilitating their interaction, and it's clearly designed with that user in mind. If you analyze the size of the keyboard, the distance between the keys, the number of keys in a row, their placement, you will realize it's all very carefully designed for human hands. Same for mouse. These facts, you will find them true in every abstraction. On top of these basic facts, there are different shades of abstraction, and some shades of abstraction are more common than others. For example, abstraction as an interface is something that you will find true in all the abstractions. In all the abstraction examples that we have seen so far, we saw an interface. Let's see some more. How about Google? This is an interface that you use to interact with the underlying search engine. Passenger, ticket counter, flight services. The ticket counter acts as an interface to flight services for the passenger. How about a remote control car? It's quite similar to a TV remote example. That's an abstraction, and the remote is the interface. The difference is, the TV remote is designed for someone watching from a distance, while the car remote is designed for a child who wants to play with the toy. This also illustrates the what and how distinction, which is another very common shade of abstraction. The kid is focused on what the remote does, without needing to know how it works. And similarly, a joystick, same thing. The joystick is the interface, and it clearly shows the what and how distinction, just like the remote. And this steering interface is specially designed for a car racing game, and this bike interface for a bike racing game. These are all user-friendly interfaces. The user is focused on what they want to do, without worrying about how it happens. Also, in all these examples, the internal details are hidden, and each interface is carefully designed with its user in mind. And similarly, many other games in the kids play area like this, and this. All of them are examples of abstraction. But how about this door lock? Is this an abstraction? Let's see. There is a user, an underlying locking mechanism, and an interface to open, lock, or unlock the door. Does it hide any underlying details? Of course, it does. The actual mechanism is hidden inside this user-friendly interface. Also, if you think about its height, its placement on the door, and the design, it's clear that it's made to facilitate the user. So yes, that's definitely an abstraction. Now, think about one more aspect. On the inside, there's a button to lock or unlock the door. But on the outside, there's a key interface. Why? Because that's how the user needs it. Anyone inside can lock or unlock with the button, but anyone outside must have a key to get in. See how carefully it's designed according to the user's needs, adhering to the abstraction design principle that you will find everywhere. Design for the user. This is something that we often miss in the code. To get the benefits of abstraction in code, we need to make sure that we always design the interfaces according to the needs of its users. How about some more advanced locks like this one that works with a password, or this one which uses a thumb impression? All of these are examples of abstraction. The purpose of these advancements is to better facilitate the user. See how our world and our daily interactions are full of abstractions. Let's move on. Now how about this simple handle, which is commonly used in cabinets and drawers? That cannot be an abstraction, right? To your surprise, they can be seen as an example of abstraction. Look closely. The underlying mechanism that opens the cabinet is the hinge. The user doesn't interact with the hinge directly. The handle acts as a simple interface that hides this complexity. The same applies to the drawer. At this point, you might feel a little confused, or you might be wondering, if we look at things that way, then anything we interact with could be called an abstraction. To clear the confusion, it's important to define what exactly makes something an abstraction. And for that, just like we have seen examples of what is an abstraction, it's equally important to look at examples of what is not an abstraction. So, we saw a door lock. That's an abstraction. But what about this one? Is this an abstraction? The answer is no. This is an interface we use to lock or unlock the door, but it's not hiding any details. We are dealing directly with the mechanism. An abstraction must hide the details. Every abstraction is an interface, but not every interface is an abstraction. If the implementation exposes itself directly for the interaction, then it's not an abstraction. In short, an abstraction must hide some underlying details behind an interface. In this example, we are interacting with the actual entity directly. Nothing is being hidden. So this is not an abstraction. But with all of these other locks, the actual mechanism is hidden behind a user-friendly interface. That's why those are valid examples of abstraction. Similarly, here's a shoelace. We interact with it directly, so it's not an abstraction. But look at this one. It adds an extra layer of abstraction. An interface designed to make it easier for the user. That's what makes something an abstraction. And similarly, this stick we saw earlier is an abstraction because it has an underlying functionality. But this one is not. Likewise, this one is not an abstraction, but this one is. By the way, sometimes it depends on how you look at things. Some might argue that the handle isn't a perfect example of abstraction. Those hinges and drawer wheels just make the experience smoother. But then there are more advanced implementations. For example, in some cabinets, the lights turn on automatically when you open them and turn off when you close them. That one is definitely an abstraction. The point here isn't to create a definitive list of real-life abstractions. The idea is to explore different examples, get familiar with the concept, sharpen our understanding, develop the skill of abstract thinking, and build practical wisdom. The goal is to make the concept of abstraction feel natural to us. And the best way to do that is by learning through examples. That's why you will see plenty of real-life and coding examples throughout this season. Season 2 of the Code Like an Architect series, Abstraction in Action. How about a water tap? Yes, that's an abstraction. It hides the underlying mechanism and offers a user-friendly interface. Another shade of abstraction is layering. See this example. Buyer, broker, seller. As you can see, the broker is serving as an interface, taking care of the underlying operations. But you can also see this as an additional layer of abstraction or a middleman. By the way, a broker is a two-way interface. You can also look at it this way. Similarly, buyer, shopkeeper, shop items. Patient, hospital reception, medical consultation. Investor, portfolio manager, portfolio. All of these act as interfaces, providing a layer of abstraction between the user and the actual system. Now see this one. When you think in terms of fruits, instead of naming each one individually, that's a conceptual interface. And it also gives you the ability to generalize or see a high-level representation of a whole category. Same with birds. These are the examples of abstraction best understood through the lens of generalization or as a high-level representation. By the way, just as an experiment, suppose you show a 2 or 3-year-old child a parrot and then tell them it's a bird. Then you show them a pigeon and say it's also a bird. Later, an eagle, again a bird. Now the next time they see a sparrow for the first time, they might come to you and confidently say, that's a bird. After just a few examples, the child starts to form a general concept of what a bird is. These are the early signs of abstract thinking, starting to see the common idea behind different things. And the interesting part, a child begins to develop the skill of abstract thinking as early as age of 2 or 3. Yet many software engineers still struggle to apply abstraction in programming. How about the concept of a question, which could be an MCQ, a true-false, a summary, or even an essay, or a general category of an electronic device? All of these are abstractions as generalizations. Take tool or vehicle as more examples. How about animals? Just like the birds and fruit examples, it gives you the ability to generalize. In addition, it's a high-level representation of a whole category. How about abstract art? It's a high-level representation of different underlying interpretations, and that's definitely an abstraction. By the way, we can also see this as a symbolic representation of an underlying reality, which is another shade and another way of looking at abstraction. Now see this. The alphanumeric representation is a higher-level symbolic view of the binary form. How about an emoji? Another example of a symbolic representation. Note one more thing. If someone sends an emoji, it can be interpreted in different ways. Same goes for abstract art. It can have multiple meanings. This means there can be multiple possible implementations of a single interface. And similarly, there can be multiple interfaces of a single implementation as well. Let's see these two key points in practice by looking at the famous ATM example. Multiple interfaces, multiple implementations. An ATM is an interface that lets you withdraw money from your bank account. A deposit machine is another interface for the same account, but for deposits. The bank counter, that's another interface. And your mobile app, yet another one. So here we have multiple interfaces for the same account or for the same underlying implementation, meaning multiple interfaces for the same implementation. In addition to that, different people can use the same ATM to withdraw from their own accounts. In this case, same interface, but multiple implementations. And same goes for the counter and the mobile app. Multiple users, same interface, but each accessing their own accounts. So what does this show? It shows that there can be multiple interfaces for the same implementation and multiple implementations behind the same interface. See another example. Visitor, reception, company. The reception is the interface to access the company's information, and so is the company website. Multiple interfaces. Now think of a light switch. That's your interface. You can always change the light at the other end of the switch. Multiple and interchangeable implementations. You can also connect 10 different lights or even other devices to a single switch. That's an example of multiple implementations behind a single interface. All of them used together at the same time as a collection. That's yet another interesting application of abstraction. See, in the real world, those elements can be connected in countless different ways to serve different needs. Once you truly grasp how these abstractions are used in real world, you will realize that programming offers the same freedom, and you can use that freedom while coding, unlocking far greater power, flexibility, and a much better design than what developers usually settle for. By the way, that switch is simplifying things for us as a user and reducing and hiding a lot of complexity from us, isn't it? Abstraction gives you simplicity and reduces complexity. Think of an AC remote, making things easier for you. Similarly, the underlying physical servers and all the networking hidden behind a cloud interface, reducing complexity. Think of a voice assistant when you ask it to set an alarm. Think of a spray nozzle on a perfume bottle. Is it an abstraction? Definitely. It's giving us a user-friendly interface, carefully designed for the need. and it's providing simplicity and convenience. How about a car ignition button that hides a lot of complex mechanisms underneath, or a power window switch, giving us effortless control? As you go from manual to automatic to autopilot, each shift in the interface simplifies your experience and hides more of the underlying complexity. Look at all these buttons around you on the microwave oven, or the washing machine, the blender, the stove, the range hood, and other appliances like these. All of these are examples of abstractions simplifying your interactions by abstracting away the complex mechanisms behind the scenes. Think of a power outlet. It's hiding complexity. In addition, it also provides generalization and swappability. You can keep plugging in different appliances, yet use the same outlet every time. That's swappability. How about a credit card reader? Same machine, different cards. Think of Bluetooth. Same interface, different devices. That's swappability, where you can keep changing the underlying implementation behind a generic interface. A light fixture. Same interface, different bulbs. A SIM card slot. A camera lens mount. A RAM slot. An SD card slot. All of these give you the benefits of generalization and swappability. You can keep changing the implementation without changing the interface. They are swappable because all of those implementations follow the same interface. Now think of a blood pressure monitor. You can see it as an example of abstraction from two perspectives. From one side, it hides the complex calculations inside. That's abstraction. From another side, it serves as an interface connecting to the human body. And when the same machine is used on different patients, that's swappability in action again. A shower head fitting. You can keep swapping out the heads. And by the way, this also gives us extensibility, meaning it lets us build on top of existing abstractions, because a tap is already an abstraction, and now we are layering more convenience on top of it. Think of a USB port. It gives us a simple interface to connect a USB. Now, when we plug in a USB extension, then connect a charging cable, and then attach headphones to charge, this is extensibility. What we are doing here, we are building on top of existing abstractions, layer by layer, adding more functionality without dealing with the underlying complexity. Similarly, from binary to machine language to intermediate languages, then to high-level languages, and now possibly an AI-based layer next in the line. We are building on top of each layer of abstraction. Each new level gives us more power, more ease, and less complexity. Or look at this, a wall socket connected to an extension cord with a 3-pin adapter plugged in, and then a hand mixer connected to it. And finally, different beaters. This is another example of extensibility. Think of any converter that hides technical details for you. That's abstraction in action, and it allows you to keep building on top. An audio jack converter, AC to DC adapter, car charger adapter, CLR to 3.5 mm converter, an HDMI cable, a mic connected to an audio interface through an XLR cable, and the audio interface in turn connected to a PC through a USB port. Abstraction. It lets you build and innovate on top of what's already there. As a user, when we use abstraction, we stay independent and decoupled from the underlying implementation. This means even if the inner workings evolve, the way we interact doesn't have to change. And this improves maintainability at user's end. Think of a car. As long as the steering wheel, accelerator, and brake stay the same, you can drive any model, even if what's under the hood has changed entirely. As long as the driving interface stays consistent, you don't have to relearn how to drive every time you change your car. Now think of a save button in a web app. Behind that button, the code may evolve. The backend may be rewritten. The architecture may transform completely, but your interaction stays the same. You still click save and your data is stored. No matter what changes behind the scenes, users remain unaffected. That's abstraction ensuring maintainability on the user's end. DNS is another good example. You type an address and DNS resolves it to an IP address. The IP might change 100 times, but you keep typing the same domain. If we had to interact with the IPs directly, any change of IP would keep breaking our side of things. Think of an electric switch. The appliance at the other end might change entirely. Each appliance can have entirely different turn-on mechanisms, but we don't care. We still flip the same switch to turn it on or off. Look at power buttons on electronic devices. Inside, the boot logic might change across models or generations. But as long as there's a power button, we know how to use it. We don't have to adopt every time. If the interface stays consistent, then even when the internals change, our experience as users remains unaffected. In most cases, we don't even notice that something has changed underneath. That's the power of abstraction. It improves maintainability by decoupling the user from the underlying details. This is abstraction. Can you think of more examples of abstraction? Remember, the best way to learn abstraction is through examples. They help you develop the skill of abstract thinking and practical wisdom. Think of an abstraction you are using right now. Maybe an operating system. It's your interface to interact with a computer, and it hides from you a lot of complex and low-level details. A browser. It lets you access the web without worrying about how HTTP, HTML, or other networking protocols work. YouTube, Google, or any other software. It may expose interfaces in the form of mobile apps, web apps, desktop apps, CLI version, third-party APIs, and so on. And users uses those interfaces to interact with the software. Now, think of an abstraction that is designed for the user and helps facilitate their interaction. All the abstraction examples that we have seen so far were designed for the users. Look at these interface advancements. What's the difference between this mouse and this one? Physical buttons on old televisions versus the TVs with remote controls. Wired headphones versus the wireless earbuds. What's the purpose of these advancements? The purpose is to better facilitate the user. They are all about creating improved designs with the user in mind to make interaction easier and smoother. One key takeaway for developers from real-life examples is the abstraction design principle. Always design for the user. Unfortunately, this is something that is often overlooked by developers. You will see this principle consistently in all real-world abstractions, but it's frequently missed in code by most developers. Now, can you think of some abstraction examples with read interfaces? How about a charging light that indicates whether a device is charging or fully charged? Or the elevator floor display that shows which floor you are on? Or the car's fuel gauge? Or even the traffic lights? These are all the examples of read interfaces. They give us key information about what's happening behind the scenes. They hide the underlying complexity and simply present what the user needs to know. Think of some everyday abstraction that you use without realizing it. How about language? The words we speak or write. When we want to interact with someone, we can't access their thoughts directly. We use language as an interface. Or how about a book? We can't access the author's mind directly. Instead, they share their knowledge through the book, and we read it to learn their opinions. A book is an interface. Maybe in the future we can have devices that can access a person's thoughts directly. That would be an interface too. And maybe people won't prefer to expose themselves through those interfaces. Or maybe such devices will be used in investigations or in the medical field. By the way, we already have devices that do similar things, like a lie detector. We already saw the blood pressure monitor earlier. There are many other medical devices that work in a similar way, like an X-ray machine. All of these act as interfaces that abstract complex internal systems and present useful information to the user. Think of some home automation examples. You can control home appliances through switches, remotes, apps, voice commands, or motion detection. That's multiple interfaces and multiple implementations. You can automate watering the garden at 7 a.m. daily or set different themes at home. This gives you the benefits of simplicity, extensibility, generalization, and maintainability. Our world is full of abstractions, making life simpler. Can you think of more examples? Vending machines, yet another famous example of abstraction. Water dispenser, a wall clock with the knobs on the back to set the time. Those knobs serve as the interface. Letterbox, you drop in a letter and the entire logistics chain is hidden from you. Same for a feedback box. Think of a restaurant. Customer, waiter, kitchen, supplier. Each one is a layer of abstraction. We talked about door locks. What about an automatic door where the interface is a motion sensor? We saw the bicycle handle example. How about the pedals? Another abstraction over the mechanism that turns the wheels. Finally, the most important one, and probably the most valuable for you. Remember, working on 100 examples of abstraction yourself, seeing how they fit in the big picture, and using them to understand the different aspects of abstraction is not same as watching someone else do it. So here is something for you. Try to create 100 examples of your own. If that feels too much, aim for 10 examples. Use ChatGPT to help, but make sure you do the thinking. Start with just one. Take the first step. So, I leave this last example for you. Doing this activity yourself will help you build the skill of abstract thinking and get you ready to apply it in your coding. Now, look around you and find the 100th example of abstraction and help me complete this video. If you want, share your examples in the comments. I would love to see what you come up with. Also, if you have any questions, feel free to ask me in the comments. Now we are ready to see abstraction in programming. Next, in the season 2 of the Code Like an Architect series. Abstraction in action.